Hello, this is Pratap. I am from IIIT Bhubaneswar, and today I am going to teach you about the introduction to data structures. Here, the scope of lecture. First we cover introduction, then basic syntax, then primitive and non-primitive data types, then type of data structures in which we study about linear and non-linear, then static data structures, dynamic data structures and their advantages. So first we are defining what is data structure. Data structure is nothing but storing data in such a way that we can use this data very efficiently. Storing the data which we can use efficiently. So, like if you are storing the data in such a way that they are using the number of variables in a different data types. As you are already familiar about the data types, let us start with the basic syntax. The basic syntax for the data structures are like in struct, if you are creating a simple data structure, then simple int x character ch. This is the basic syntax for the data structure. In here we struct represent the structures name called simple, and inside the structure I defined integer data type or name as x and a character data type ch. So basically data structures comprises of lot of data inside it and many others data type like character, float, double, integer, primitive and non-primitive data type. First, primitive data type. This type of data type store a single value. This type of data type stores a single value. Like example, integer, float. Integer like 6 if we defined if int x is equal to 6. So it is categorized under integer data type. Float. In float data type, if we define float x, then if the value of x is this, then float of x will print it out as output is 6.000000, 60 after decimal. So it is a float data type. Next, character data type. In character we define a single character like C, A, any single words, single data types, right? Next, non-primitive data types. Non-primitive data type it stores the more than single value. This type of data type are derived from primary data type. Examples: array, stack, queue. As you already know that array is a continuous, it's stored a value like this. Suppose this is an array of size 20, index number 0, 1, 2, 3, 4, 5, 6, and so on. In stack, this is LIFO rule is applied. LIFO stands for last in, first out. Here we put a value like 6, 5, 4 if we push the operation, and if we popping the operation, then if we popping like 4, then the final stack, this is 6 and 5. 4 is popped out from this. In type of data structure, first linear data structure, and non-linear data structure. First, we define what is linear data structure. Right. So in linear data structures, the structures which are in the form of sequence, like in one sequence, like array. If we see the array, it is in continuous form, linked one to each other, like in link as well. List. Suppose we are writing this list. And each are attached to member. Storing address 1, address 2, address 3, address 4, and null value. This also comprises the array of size 10, index 0, 1, 2, 3, 4, 5, and 6, and storing address 1, address 2, address 3, address 4, address 5, address 6, and address 7. So this consists of linear data structures. The data structure which is in the form of linear fashion. Example are array, list, etc. So let's see have the data structure which is in the form of linear fashion means continuous. Non-linked web array, list are the example. If we see the basic syntax of creating an array, we construct like class. We input int roll number, character name of size 20, float, CGPA. So a simple array data structure which defined an integer data type called name roll number, character names 20, and float CGPA, in which stored a data of a class of a student who is representing roll number, his name, his CGPA, and finally display to it. So it is in the form of primitive data type. Second, non-linear data structure. It is just opposite to the linear data structure. Like the data structure is said to be non-linear if it make a sequence like array, like stack, right? It not make a sequence like list. It's like let's say graph. tree. In graph we see this type of patterns form 1, 2, 3, 4, 5. Right. So in graph, it is not linear, it is non-linear because it not make a sequence. If we go from 1 to 5, then we travel from 1, 3, 4 and 5. And another path is 1, 2, 3, 4, 5. So a lot of paths, so it is not a linear data structure. Another is tree. In tree as well, this is the parent, this is a child, child, subchild, child. In this sequence also, this is level 0, this is level 1, this is level 2, and this is level 3. So suppose this is 6, 5, 2, 4, 7, 9, 8. So this type of structures is known as non-linear data structures. Moving on, the main difference between linear and non-linear data structures. First, the linear data structures. I already discussed about linear data structure. Data structure is said to be linear if it makes a sequence. For example, array, linked list. Whereas in non-linear data structure, the data structure is said to be non-linear if it does not make a sequence. Example, hash, tree and graph. As we see that in array, suppose take an array and name of this array is suppose character, name, car, 50. So it stored a value 50 and move on, right? And stored the name, the character data type, right? A, B, C, D, E, F, G and so on, right? So in uppercase character and lowercase characters too. So in this it is a continuous, so it's make a sequence. Continuous. So whereas in linked list as well, if you see different type of nodes, these are called nodes. These are called nodes. So they are linking to each other. So that's why we call it linked list. Suppose this is a head, and this is 1, 2, and this is finally null. Right. So it linking and form a sequence. So it is in under linear data structure. Continuous, then it is a linear data structures. Coming to the non-linear data structures, in the tree, see in tree we see there is a parent and there is child. One parent comprises two child and child has their own childrens, like this. So it is a form of tree. Later we discuss about the tree and how it is used. Now there is it is in form of non-linear data structures. Comprises 5, 4, 2, 7, 8, 9, 12, 11, 13, 14. So tree, it's a level 0, it's a level 1, it's a level 2, it's a level 3. So it is a form of tree. It is in the non-linear data structures. Coming structures. So graph is like this. This is an example of graph. Okay. So it comprises 1, 2, 3, 4, 5, 6. So this form of graph, it is not a sequence, it does not make any regular continuous, so it is in the form non-linear data structures, right? Suppose this is a type of node 1, node 2, node 4, node 3, node 5, node 6. So if we want to travel from 1 to 6, then we can say there's a lot of part 1 to 3, 3 to 4, 4 to 5, 5 to 6. If you travel very sequence 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So a lot of sequences made. So it's a graph is another data structure as an array. We defined an array of size 20. So it is defined, right? Array name, here we defined the array name. Here define the size. So its size is fixed. So here that it defined the collection of data in memory that is fixed in size. That is fixed in size means the size is already defined, right? So in here the array name defined A and the size of an array is 20. So make an array, as we know, right? This is an array, and this is a array of size 20. We stored an array, like let us say that's an integer data type. So taking an integer, storing in an array integer data type of size 20. Suppose we're storing 5, 7, 6, 9, 12, 0, 1, 15, 17. Suppose we're storing this type of data type, and the index number 0, 1, 2, 3, 4, 5, 6, 7, 8. It's making more. 9, 10, 11, 12, 13, 14, 15, 16, 17. So 21, 25, 24, 23, 22, 21, 20, 19, 18. So this is an array of size. Suppose we're taking 18, so let's say it's 18, right? So it's not possible. 5, 7, 6, 9 is an array of size 20. So we defined an array so size is fixed, not be changed after in the runtime. Main point, it cannot be size, its size. Simply say size can't be changed during runtime. So while executing this and during runtime, where compilers takes input, and this is the fixed array, you input the array, right? Like suppose in a structure with struct array integer array of size 18 integer x. So define a structure and struct array 1 and defining that 5, 7, 6, 9, 12, 0, 1, 15, 17, 21, 25, 24, 23, 22, 21, 20, 19 and 18. Lot of data. So if you print this data, let's write a printf statement for this. To print a data of size array 1, right? So basically in static data structures, the size are fixed and memory can be reallocated later on, and the most important point is size cannot be changed during runtime. During runtime, you cannot change the size of an array, shrink or. So coming to the dynamic data structures. So first, what is the definition of dynamic data structure? Dynamic data structures it is defined as the collection of data in memory that has the flexibility to grow or shrink in size. Dynamic data structure by having unused memory allocated. So dynamic data structure is defined as the collection of data, is also a collection of data in which in memories that has the flexibility to grow or shrink in size. Means in a static data structure we study about the size and flexibility is constant, means size cannot be changed during runtime, but in the dynamic data structures can be changed during runtime. So it is a flexible and grown or shrink in size, right? The size is not fixed during runtime as well. Dynamic data structure having unused memory allocated. One of the prominent example of dynamic data structure is linked list. In linked list we see a lot of nodes are there. Suppose this is a node 1, node 2, node 3, node 4, node 5. Here, this is the head. This is address 1 having address 2 having element address 3, and this is finally null. So it's finally a consequence sequences cannot be in the middle of the during runtime cannot be it can be shrink or change the size. Like suppose if this linked list has a size of 6 elements, then if you introduce an adding an element or deleting an element, right? For adding an element or inserting an element in the linked list. Suppose you want to adding or inserting a linked list in node, let's say in node 2 between 2 and 3. So first in the coding we have to just for the node 2 we have to just link it to address 4 and node 5. So we have to introduce a node 5 between 2 and 3. So node 2 is referred to address 4, that is referred to address 4, and address node 5 it address to node 3 and is allocate the address of node number 3. So like this we introduce this data. So first this arrow, this link is going to this way, and thus this, and this node 5 and address comprising of address of element address 5. So now the link is like the address 2, address 5, then address 3, then null. So inserting an element like this in a linked list, so its size changes. Now the size of this linked list is 1, 2, 3, 4, 5 and 6 and 7, right? And later on, similarly in the case of deletion, the link, if want to delete the array, first to delete this, first you have to link to this element, that is node number 3, and then we just move on, and this element, this node and can be deleted from this point. So here the dynamic data structure, we already defined the memory, that is flexibility of ground strings. Here we see that in the linear data structures, it can be string, the size can be changed. When inserting or deleting an element, inserting an element the size increases, deleting an element always the size decreases. So it is comprised under the prominent example of dynamic data structures, that is the link. Static data structure and dynamic data structure. In static data structure, the important point is the size is fixed, which means that it can't be shrink or grown. Second, important point, during runtime. Example of static data structures you see an array where in the dynamic part the size is shrink or grown during run time as well. Examples are, one of the prominent example is linked list, and here the array. So important point between this is this. We already discussed an array like zero, 1, 2, 3, 4, 5, having address 1, address 2, address 3, address 4, address 5, address 6 of some element of size integer, address of size suppose 6. If I define an integer data type of size 6 and it comprises 5, 6, 9, 12, 1, 4. So in an array we have stored integer data type of name array A, and size of an array is 6. So its size is fixed, cannot be changed during runtime. Whereas in dynamic data structures, whereas in linked list, like sub-process of this, it can be changed. We can insert a node between this and delete a node from this. Right. So this is the opposite head. This is null or tail, node 1, node 2. So we can insert an element which comprises address of this address 1, address 2, and so on. So we already covered about the static data structure and dynamic data structures. What's the use and what are the examples of between these use? Advantages of data structures. So we see in the dynamic data structure, and in static data structure. In dynamic data structure, it is fast access, slow access. It is flexible in size, means you can shrink or create new node and array. Examples for this is a linked list. Whereas in static data structure, it is fast access, you can easily get in data from this. It is fixed in size, and one of the prominent example of this is array. Prominent example of static data structure. So advantage of the main points are slow access in dynamic data structure is slow access, obviously because inserting or deleting data during runtime, flexible in size, and examples are the linked list. In a static data structure, it is fast access, sequence form in array. We see in array it can easily be search found, which is we can easily search or sort it out in array. It is fixed in size, already discussed about why it is fixed in size, and examples are array. So these are the advantages of